Hey everyone, I'm a small lizard and today I hope to be able to convince you guys to bring your GC for your Chem papers. Why? To solve these types of questions, hopefully in a faster way. So we have metallurgite, a copper carbonate hydroxide compound, and the formula is given right there and has the following composition by mass. So you have the four elements: cuprum, aka copper, hydrogen, oxygen, and carbon. What you guys would do is basically draw this table and assume that there are 100 grams of metallurgite. From there, we then can calculate the mass of copper, oxygen, carbon, and hydrogen in 100 grams of metallurgite. Because we're solving for x, y, and z, which are mole ratio, we need to find first the mole and then subsequently the mole ratio. In order to find mole, you have the mass of each element. Now you just need the atomic mass of each element to find the mole. Alright, should be pretty easy if you've actually done this long enough. Quite experienced, you know that, well, copper, carbon, hydrogen, basically 63.5, 16, 12, and 1. Now, from here, you guys would do is take your scientific calculator or for some reason your graphing calculator and you divide each of them by 1 by 1. Right, 37.5 divided by 63.5, 36.2 divided by 16, 5.43 divided by 12, and well, 0.905. Don't really need to use a calculator, divided by 1. We'll still give it back 0.905. Kind of slow, because what you guys need to do is to scroll up and down to obtain the value. So, what's the faster way? And it's actually in your GC. In the GC, there's this thing called the list function that you can use to calculate all 4 moles at once and easily calculate the mole ratio from there. This is how you can do it. Alright, so here I have my GC and snowball right here. And basically how to use the GC to calculate the mole in a faster way. First, go to your list. So click on Stat, Edit. Alright, do not go to this list right here, just to show you guys what is in this list function. Basically, it gives you just the names and the different operations and the method you can do. But you want to edit the list, click on Stat, and then you see Edit. Alright, now over here, because we want to find the mole, so what we're going to do is I'm going to list down. The first list will be the mass of each element in the metallurgite. Thereafter, we want to find the mole, so we need the atomic mass of each element, so 63.5, 16, 12, and 1. Now, from here, I will then move on to L3. So when you move the next list to another, you'll be moved to the top cell. But what I'm going to do is go to the title of the list, and because on how mole can be found is basically the first list divided by the second list. Down here, you can see that there's L1 and L2. So I'm going to go second one to give me L1 divide by L2, which is right here. And when I click on enter, you notice that we'll be given the moles of each compound, or rather in each element. And pretty fast, right? And you want to find the mole ratio, what you can do is divide by the lowest number available. So we go to L3, divide by point, well, that is 4525, so 0.4525, just 0.45 will do. And we then notice that in the last list, we get the mole ratio of 2, 5, 1, and 2. Alright, so this is how we can use the GC to find our mole and mole ratio in a quicker manner. Now that you have the results, simply put them inside the table: 0.9055, 2.2625, 0.4525, and lastly 0.905. Mole ratio is 2152. So from here we know that there are 2 moles of Cu, so Cu2, 1 carbon, so only 1 carbonate. And then now you just make sure your math is correct. After 1 carbonate is gone, you're left with 2 O's and 2 H's. Yep, just nice, 2 OH. Therefore, we have X equals to Z equals to 2, Y equals to 1. Alright, so that's how we can use the GC to solve these types of questions. So let me repeat the steps involved. Alright, so first step, well, draw the table and all that. Now we put in the percentage by mass on the first list. And second list would be the atomic mass. Thereafter, hover over L3 in your second step and key in L1 over L2 to give you the mole of each element in 100 grams. Click enter to give you the mole. Now you want to get to the mole. Now you just want to find the mole ratio. Divide by the smallest number, which is 0.4525. So in L4, L3 divided by approximate value is good enough, 0.45. You'll get a very close value, as you can see right here, and this will just obtain the mole ratio of the elements. Alright, so there we have it, why you should bring your GC to your chem paper, and I'll catch you guys around.